Hello and welcome to another video from In3D Software. Today I want to talk about draw boxes and particularly in-house made draw boxes. So let's make a quick article. I'll go to the designer, article designer, and then in here I'm going to say that this is 250 by 250 with a depth of 250. So I've got a small cube. And then in here, I'm going to add in my top, bottom, left and right, and I want to add in a drawer as well. So once I've got that, I can then zoom in on it. So here's my draw box, and in this case, I'm going to drop it down and I'm going to choose an underfloor guide as my draw box. If I go to the construction principle by clicking on the red dots, you can see in here we have a construction principle for a made draw box now. And when I click apply and then tick, we'll go up in our level of detail. And because I've made the cube so small, there's no draw runners in the system. You saw the connection scan pop up there. If I just run the connection scan again, you can see that there's no selection available. And this is because there's no Quadro draw runners that will work in this size. So if I simply stretch the product, and in this case, I'll say overall, this should be 450 millimeters wide. And in the depth, I'll say overall 450, and in the height, overall, let's say 350. If I now refresh, you can see it's brought through a draw box in here. Now, if we look at the draw box and how that's actually constructed before we bring the runners in, if we look at it from the front view, you can see that we have a made draw box in here, but no fittings connecting this thing together. So effectively, this will fall apart. So what we need to do is add some fittings to the sides. And then look at how this is grooved into the front. If we look at it from the right hand side, you can see that the bottom is short to the front by default, and again we might want to change this. So the way we would do that is modify the article, click on the draw. Within the draw, go to the construction principle by clicking on the red button. And then in here, we can then go to the construction, and you can see we have a series of values that control the minimum distance between the different parts of the draw. In here, the picture shows us this is the draw bottom, and this is going to be a 2 mil gap by minimum in here. The same for the distance between the top and the underside of the top. So these values can be tweaked, and it will then take the closest height value of that particular draw box system that we've designed. In here you can see it's jumping up in 10 mil increments. We then have a greater jump. The same applies to the depth. It will choose the closest depth runner for that box. So in this case I have 450, 420, 400, and if there's a draw runner that will ask for a 410 draw box, it will then it'll miss that and then switch to the 420. If we go to the draw front, under construction, you can see I have a part definition draw front that's assigned in the form of a variable. And then if I go into the shelf, you can see in here we've got our draw box bottom part definition. For the sides or the vertical sections, if we open up this section, we now have these 4 sections, and when I click on them, it will highlight in red each of the parts. If I open up the first one in here, what I can do is go in and assign a fitting. In this case, to the previous part. Remember, we always work anti-clockwise, so the previous would be the left-hand side in this case. I want to now assign, for example, a conformat screw. I'm going to also do that to the next part, which would then be the right hand side. If I go to the back panel, I can do the same again. And then once saved, if I apply and tick, you'll see that the system will then refresh. So again, I'll just come in and run a connection scan on this. And in here, I can now choose the draw runner that I want to go for. In this case, I'm going to go with just a standard 420 deep system draw runner. And then it's going to ask me for the wood screws. So you can see it's now assigned fittings to my parts for me, and it's put the drilling in here as my through drill. Okay, so the next thing that I want to do is look at how this back panel in here interacts. So you can see in here, the runner is going to push a drilling into the bottom of that back panel, and I'm happy with this because it means that it can now be drilled in here as part of the construction process. And then if we look at the front in here, I want my front to stop short and to run all the way through. I'll right click modify, click on the draw box again, go to the construction principle by clicking on the red dot, and then in here, if I go to my front, you can see that I've got the joint with the shelf is set to long. I can then change that to short, save, apply, tick, and this will then refresh. And you can see now that the drilling has been passed into the bottom for the draw front clips, and it's now got a short trim on there. The next thing that I want to do is change how the draw bottom is actually connected. Now, if I right click, modify, click on the part, go to the construction principle by clicking on the red button, I can then go to in here the draw front again, and I can have a connection with the shelf. So in this case, if I was to put conformats in there, it would screw through the bottom of the shelf into the draw box front. This could be then done on any of the other sides. But in this case, what I want to do is go to the right hand side and I want to put in a groove. I'll say that the shelf joint with the shelf here is long, and I want a connection, a groove connection applied to it. In this case, I'll go to connection technology, and then in here I can find my groove, draw box groove. So I'll just search for groove, and in here I've got a connection situation called groove draw bottom shelf. I'll click apply. And then what I want to do is take that connection situation and apply it to the left-hand side as well. Now what I want to do is put a reveal to the shelf and say that I want this to groove into the shelf 7mm. And I'm going to do the same on the right-hand side and say a reveal to the shelf of 7mm in here. I'll click apply and tick. Once I've done this, you can see it's now pushed my bottom into the draw box side, and it's created a groove for me. You can see there's a tolerance on the groove as well, so it's given me a bit of tolerance in here on my groove. But what I also want to do is, if I go to the front, I want to change my draw box material. If I right click and do a measurement, you can see that in this case the material is set to 16mm board. Typically, we would use the same carcass material. So what I want to do now is right-click article related variables, select the product, right-click to confirm, go to the getting started, construction, and basic data. And then in here, I've got materials draw, and I can go to the case. And in this case, what I'm going to do is say that I want this to be $mat_1. I want the profile to be $PRF_1. And press enter. I'll do the same for the draw box bottom, $mat_1, and the draw back, I want that to also be $mat_1. Now I can set this up as a preset in a drop down as a variable family, and that way when I have this, I can drop this down quickly and specify this as an option. This means that now when I change the carcass material, in this case 19mm board to, and I'll just drop this down and choose an 18mm walnut, it will then change my draw box material as well. So you can see in this scenario, it's changed my draw runners now based on the connection scan to ensure that it's choosing a suitable draw runner. The only issue that we have is, if we look at it from the front, we need a piece of machining added into the underside of this draw box. Quite often, companies will use the same thickness carcass material as the main draw box material as the carcass, but it will require a piece of machining in here to allow it to work with the draw box runners. In this case, the easiest way to do this is to add it into the actual part definition. I will modify the product, click on the part, go to the construction principle, and then navigate to the left hand side panel. Go to the left hand side panel, and then by clicking on the name here, I can click on the red button. This will take me to the construction principle, and then when I go to the default settings, I have the part definition. When I click on the red button, it'll take me into the part definition, so I'm now 3 levels deep. In here, I can then do _GR for groove. I've saved a new version of this. Now what I can do is go to the in the new iX23 version, we can go to the machining, and in machining sections, I want to add a groove. By clicking on groove, I now have a visual indication of what the groove is going to look like. And in this case, what I'm going to do is say that this should be from the top, controlled by a linear division. I'm going to say that in X, it should start at 0 to 1. And in Y, it should start at, in this direction, I'm going to say it should start at 6 mil to 1. And then in the endpoint in Y, I want this to be 1 to 0. That will make it a full width. The depth should be set to 3 mil and the width should be set to 12. This will now give me a groove, and when I click on tick, I can click on the preview and you can see that I've now got a rebated lap joint style groove added into that part. I'll click OK and save and apply. Save and apply. Save. Let's just put that in there, _GR. So I'm saving a new version of the construction principle as well, with groove on there, and then I have one with and one without. So once I've applied that in, I want to do the right hand side panel as well. I'll go to the right hand side panel, save a new version as GR for groove, click on the the part definition red button, click on _GR for the part definition. I've saved a new version. In here, I want to then go to my machinings, and again, I want to add a groove. In this case, I'm going to go to the groove section, and this time I'm going to say it should be from the bottom, and I want to then go to linear division and then say 0 to 1, 1 to 0, 6 mil to 1. And then in here, I want the width to be 12, the depth to be 3 and the width to be 12. I'll click on the tick and let's go to the preview. This looks better. I can click OK, save and apply, save and apply, save and apply. Click on the tick and let's look at the results in the 3D model. So you can see I've now got the groove in here for the bottom of the draw box, and then I've got the groove in the bottom in here as well. So by changing the direction from top to bottom, it's effectively going to mirror that machining. Okay, that's my draw box now complete. If you have any questions, please let us know. Thanks for watching.